Okay, let's grade test for the test for chapter 6. Define the following terms. A, physical change. You should have said something about a change that does not alter the chemical composition. Kinetic theory of matter. You should have said something about the molecules moving and that there's space between the molecules. So they're in constant motion and there's space between the molecules. C, single displacement reaction. That's when one element or ion is replaced by another. Combustion reaction is where something reacts with oxygen and you produce heat and light. Incomplete combustion, excuse me, is where you have a combustion reaction and the products would include carbon monoxide or carbon and water, rather than carbon dioxide and water, which would be a complete combustion reaction. Number 2, identify the following as chemical or physical change. A is a stick of butter melting. That is definitely physical change because it's just changing as far as its energy level. B, it doesn't change the composition. B, strontium chloride is dissolved in water. That's a physical change. You can get the strontium chloride back. It does not change its chemical composition. C, metal boils. That is a physical change. There is no change to its chemical composition. D, a metal is used as fuel in combustion. That is a chemical change. It has actually changed its form. Number 3, aluminum boils at a temperature of 4,566 degrees Fahrenheit. What is its temperature in Celsius? And so, let's plug those in. We have 4,566 degrees Fahrenheit equals 9/5 degrees Celsius plus 32. Okay, so now let's go ahead and we gotta get this guy over here. So we're gonna go minus 32. So that's gonna be 4,534 degrees Fahrenheit equals 9/5 degrees Celsius. Okay, and then we are going to divide both sides by that. So we're gonna multiply it by its inverse. And that's going to give us a temperature of 2519 degrees Celsius. 2519 degrees Celsius. 2,519 degrees Celsius. This goes to the ones place, this has to go to the ones place. Okay, pretty hot stuff. Way too hot for me. The melting point of gold is 1,945 degrees Fahrenheit, while its boiling point is 5,173 degrees Fahrenheit. Is it a solid, liquid, or gas at 3,315 degrees Celsius? So you need to find out how many degrees Fahrenheit that is. So once again, here's our Fahrenheit equals 9/5, and we're going to put in here our 3,315 degrees Celsius plus 32. And so when you do the math, you're going to end up with 5,999 degrees Fahrenheit. And so you look back at what he told us, and at that temperature, it is above the boiling point, because remember the boiling point was this. This temperature is hotter than the boiling point, and so it's going to be in the gas phase. So the answer would be gas, but this is how you determine that. And let's see if he's actually giving you points. That's number 4. Yeah, he gives you points for converting it to the Fahrenheit and then for the answer. Like each one is worth a half a point, and we better figure out what half a point is worth, huh? It's going to be close to 3. Yeah, each problem, let's just say each problem's worth, each point on this one is worth 3 points. And he tells you that you get, it's 3 points for the whole thing. This is worth half of the credit, so 1.5 points, and this is worth, the fact that this will be a gas is worth half of the answer, so 1.5 points. Okay, let's see. 5, a substance turns from the liquid phase to the solid phase. Did it gain or lose energy to do that? Well, if it went from a liquid to a solid, it lost energy. Number 6, a student adds 50 mils of water to 50 mils of alcohol, and reports the final volume at 100 mils. Is his report volume correct? Too high or too low? It's too high, because remember there's space between the molecules, so they'll kind of settle down into one another. Number 7, a substance melts at 50 degrees Celsius and boils at 150 degrees Celsius. Draw a heat curve for this substance, noting that there are where those two temperatures are on the graph. And so I'm going to give you a very simplistic one, but it's going to come up and then it's going to go across at, let's see, 50 degrees Celsius is where it melts, then it's going to go up again, and then it's going to go across again at 150 degrees Celsius, and that's where it boils. And so that's the basic idea of what you should have. Compare the distance between water molecules when the water is in the liquid phase at about 0 degrees and the water is in the solid phase at about 0 degrees. Well, in the liquid phase, they're closer together than they are in the solid phase. So that's what you needed to say. Balance the following chemical equations. Okay, so we have SeCl6 plus O2 yields SeO2 plus Cl2. Okay, did I get that right? Yes. So we have one of these and one of these, but we have 2 of these and 6 of these. So I'm going to put a 3 here. We have 2 of these and 2 of these. I think we're balanced. 1, 6, 2. Okay, got that one. That was nice. Okay, the next one's a lot harder because you got to come up with everything yourself. It's a solid calcium, so we have to do calcium, and we're going to put that it's a solid. Reacts with liquid hydrogen monochloride. Hydrogen monochloride liquid to make solid calcium chloride. That's a +2. I'm supposed to do it the other way, I know, +2. Chloride is a -1. So this gets the 2, the calcium gets the 1. And we said here that this is a solid plus hydrogen gas. There we go. Make sure the phase symbols are in there. That's worth 1 point all by itself. And let's see how he does these. 9. Yeah, see, that one is worth, you get 3 points just for getting this part correct. If you've got that far correct, you get 3 points. And then to finish balancing it, it's worth another 3 points. So let's say you didn't balance it correctly, you take off 3 points, as long as you got this part correctly, okay? Okay, so, and of this 3 points, I would say you need to have the phase symbols. So if you left off your phase symbols, take off 1 point. Okay, now we have 2 of these, so we're going to need 2 of these. We have 2 of these and 2 of these. So let's see. 1 calcium, 1 calcium. 2 hydrogens, 2 hydrogens. 2 chlorines, 2 chlorines. So you're good. Okay, let's go to C. C is potassium hydroxide, aqueous, plus, you could do these right in your test, so you didn't have to write all of these out like I have to. Aqueous plus water, liquid. Okay, let's make sure I got that right. PO4, K3PO4. Okay, so we have 3 potassiums here, so we're going to have to put a 3 over here. We're going to leave the oxygen and the hydrogen till last because it's split. We have 1 phosphorus here and we have 1 phosphorus here. So we've got 3 potassiums on both sides, 1 phosphorus on both sides. Let's deal with the hydrogen next. We have 4 hydrogens. And here we have 2 hydrogens. So let's do that. Okay? Now we have 4 hydrogens, and here we have 4 hydrogens. Okay, let's check our oxygens. We have 3 plus 4 is 7. We have 4 plus 4. Oh, 3 plus 4 is 7. 4 plus 2 is 6. Did I do something wrong? 3. Yes, yes. Oh, yes, I did something wrong. So let's go back. I don't know what I did. Okay, we have to have, here, start over. We have to have 3 potassiums on both sides. So we're going to put a 3 here. Yeah. And then we have 1 phosphorus on both sides. So we're okay there. We have 3 hydrogens plus 3 hydrogens is 6 hydrogens. So we're going to put a 3 here, and that gives us 6 hydrogens. Now we can deal with the oxygen. We have 3 plus 4 is 7 oxygens, and we have 4 plus 3 is 7 oxygens. So we're in good shape. So we have 3 potassiums on both sides. We have 3 plus 4 is 7 oxygens on both sides. Here's your 3 plus 4. We have hydrogens. We have 3 plus 3 is 6, and I have 6 over here, and then 1 phosphorus on both sides. I know, that was hard. Sort of. Some of you are going, that wasn't hard. Some of you are going, yeah, that was hard. It's okay. Let's do D. Okay, silicon dioxide. So we have silicon, which if you look is, oh, well, this is a covalent bond, so there's no charges. Silicon dioxide, we know that by the name, don't we? And reacts with hydrogen monofluoride, because remember, it's got the di. That's why, just in case you're wondering. To make silicon tetrafluoride plus water. Okay, so let's check. Silicon dioxide, hydrogen monofluoride, silicon tetrafluoride, water. Okay, we have 1 silicon on both sides. We have 4 fluorines, and so I'm going to make 4 over there. Now we have 4 hydrogens, so I'm going to put a 2 here, so I have 4 hydrogens here. Now I have 2 oxygens, and I have 2 oxygens. Let's check. 1 silicon, 1 silicon. 2 oxygens, 2 oxygens. 4 hydrogens, 4 hydrogens. 4 fluorine, 4 fluorine. We're good. Now remember, that's going to be one of those where you get part of the points for just getting it right before you balanced it, and then the other part for balancing it. Let's see. Gold. Gold sulfide. That's interesting. Au is gold. I'll tell you in class why I know that. And Au plus H2S. Okay, did I get it right? I think so. All right, there's 2 of these, so we're going to go 2. There's 3 of these, so we're going to go 3, right? So we have 2 golds, we have 3 sulfurs, so now we have 6 hydrogens. So I'm going to come over here and put a 3, and that'll give me 6 hydrogens. And so that should be balanced. Yep. Okay. Get out of the way so you can see it. Number 10. Give the balanced chemical equation for the formation of, and we have H3PO4. Okay, the formation reaction is the elements coming together to make this. So the elements are H, P, and O. Then we ask ourselves, who gets the little 2's? H, N, O, and the first 4 of group 7, which aren't there. Okay, so then we have a 3 here and a 2 here. And so personally, I'm just going to do the 6 because I know that the lowest common multiple is 6. So that gets a 2. That gets a 3. All right, so now we have 6 and we have 6. We have 2 phosphoruses now, so I'm going to go like this. We have 8 of these, so I'm going to go like this. All right, so now we have 6 and 6, 2 phosphorus, 2 phosphorus, 8 oxygens, 8 oxygens. So that would be your balanced formation reaction on H3PO4. pretty sure it's phosphoric acid. Okay, give the balanced chemical equation for the complete combustion of pentane. And this is a liquid, and he mentioned it, so I'm going to put it in. It is a combustion reaction. It is a complete combustion reaction. Okay, there's my start. Now, let's balance. We have 5 carbons, so I'm going to come over here and put a 5. We have 12 hydrogens, so I'm going to come up over here, and I'm going to put in a 6. Now I have the right numbers of carbons and hydrogens. I have 10 plus 6. Wow, that made that easy. 10 plus 6 is 16, so I can just go like this and put an 8 in here, can't I? And that gives me 16. And so, let's check it. 5 carbons, 12 hydrogens, 12 hydrogens. 10 plus 6, or 16 oxygens, 16 oxygens. And once again, on that one, I'm sure you're getting credit for both steps. Let's look. Yes, you're getting 3 points for writing out the equation correctly. It says to take off a point if you don't have the phase symbols. I told you. And then you're getting 3 more points for balancing it correctly. Okay, let's flip the page. Go on to number 12. Number 12. Identify each of the following reactions as formation, decomposition, single displacement, double displacement, complete combustion, or incomplete combustion. The first one, we have magnesium and aluminum chloride, and then we're producing aluminum plus magnesium chloride. We are bumping the aluminum off of that molecule on the reactant side and replacing it with the magnesium. So that is a single displacement reaction. On B, we have one molecule being broken down into its constituent elements, and so that would be a composition reaction. C, we have something being reacted with oxygen, and it's producing carbon and water. That is an incomplete combustion reaction. And then the last one, you notice that the sodium sulfide and the hydrogen monochloride actually both trade. So in the next one, you have sodium chloride and hydrogen, dihydrogen sulfide. So that's a double displacement reaction. Now, once again, if you count each of his points as 3 points, you can use his information in the test solutions to figure out how to grade your test. Make sure that you start with 100 and subtract from 100 whatever you've missed. And if you have any questions on it, ask me in class. And have your parent put initials on it and then bring it in with you, please, so that we can look at that. And thank you. Go ahead and follow your syllabus and start working on the next chapter and have a Jesus-filled week, a very blessed week. Bye-bye.